it's me, your boy, once again, Mr. Giz to the Fab, G to the F to the double Z. So in today's video, we're going to machine our first functional part off the Shapeoko. So straight away, I'll address the elephant in the room, and that is the cardboard enclosure. Now, I have been doing some machining on this throughout the week, just sort of testing out recipes and etc, and just sort of getting to grips with the machine. And the first issue I come across was there was just chips absolutely everywhere, as you saw in the last video. So this cardboard box, or this cardboard wall, has helped massively in keeping the workshop nice and tidy. Eventually I will build a nice looking enclosure for it, but for the time being, this will do. We've also got our air plumbed in for our chip evacuation. We're running just pure air at the moment. I bought a little dedicated compressor for the job. It's tiny, but it does do a half decent job. We've not had any issues with it. This will be replaced eventually with a air mister. We're going to use a water and alcohol mix to keep the end mill cool, help evacuate chips. I have tried using some like cutting fluid and WD-40 type stuff, but what I'm finding is that the stickiness of it keeps the chips stuck to the piece, and you can hear the end mill dragging the chips around. So a lot of people dry cut on these, so you know, there's some success, there are success stories. So we're going to keep cutting dry for now until I eventually get an enclosure sorted and get a mister put in. So we're going to machine the outlet flange for the M62 Supercharger. Obviously we need to start with a flange so we can then build off the bits that we're going to be using to attach the intercooler hose to. So we're going to use this piece of stock here, which I've conveniently already got cut. So yeah, let's get over to the masturbation station, aka the laptop, and let's start camming this flange up. So here we are, we've got our model loaded into Fusion 360 on the masturbation station. So a bit of a disclaimer before we go any further is I've got no shaming saying that I've got absolutely no fucking idea of what I'm doing. I've been using Fusion for less than 2 weeks. I've had to CNC Shapeoko for a week and a half now. I've picked up some techniques from YouTube videos, from Dougie Doug and from Stu, who have been walking, you know, those two guys have been at my beck and call pretty much to answer any questions or any tips or needs to get the job going. So if this isn't the way that you would do it, rather than be a negative dickhead in the comments, turn that negative into a positive and actually give me some advice, because, you know, I'm open to advice. I want this machine to run the best it can. I want to machine the best components I can on the machine. So anyway, let's get cracking. So first we've got to do is set up the model and the material. So this is our model. We're going to go with a fixed size box, and we've got a 152.85 millimeters on the X. We've got 136.65 millimeters on the Y. We know the material is 9.5 millimeters thick. And what we need to do as well, this box in the corner here is important because this shows you where the model is in relation to your machine. So obviously front would be the front, left, right, top, bottom, back, whatever. So that's important. So what we need to do is, I'm not too worried about having a machined surface on the bottom and the top. I'd like a machined part on the top just for demonstration of this video. It's not necessary, but we're going to do it anyway. So what I need to do is I need to bump the model down in the stock by 0.5 of a millimeter. So we go Z, offset from top, 0.5, boom. And that puts our part in the bottom of the stock. And what we need to do is go back onto the setup screen, and we need to move, so this triad here equals where our start position is going to be. So we're going to choose this top corner here. So this top corner here is the same as this top corner here on the stock. I like to use the top because it's easily accessible on my machine. I've got to zero the machine off all manually, so yeah, it's easiest for me. So anyway, we're going to get into the next operation now. So now we've got the model set up and the stock set up. We're going to do a simple 2D facing operation. We're going to use a 6mm single flute end mill. That's what I've got. We're going to ramp it up to 24,000 RPM, which is the maximum RPM our spindle can spin. We don't need to select any geometry. The heights we could mess with, but I'm not going to bother for the demonstration of this video. You can basically speed up or slow down the process. I think by speeding up the traction, I could probably save a minute in this model. So because we've not got an awful lot of traction to do, so I'm going to skip that for this particular demonstration. Passes, multiple depths. We know we need to go 0.5mm down. That might not be a necessary step, but I'll do it anyway. Step over, we're going to bump down to 5mm. So we're almost cut in 1D. What else we got? We don't need lead in, we don't need lead out. We can start from outside of the material, so we don't need that. Go back to passes. I like to just increase my pass extension by 3mm and increase my stock position by 2mm. And if I just simulate it quickly, so what that means is it means the end mill comes out of the material fully before it enters. And on some previous jobs, what I've done, I've not adjusted that, and the end mill, because it focuses on the center point of the end mill. So the center point of the end mill will reach the end of the stock, so it will leave that 3mm radius in the stock before it continues. And although we are wasting the stock anyway, so it doesn't really matter. Yeah, I just want to try something different this time. So we're going to have the end mill come fully out before it comes back in, and then a stock offset I've just done because on some previous cuts it's left like a a bit of a tin foil edge on the end there. So by doing stock offset, that means we're going to get the entirety of the material covered in this facing operation. So next we are going to do a 2D boring operation on our holes. Now you could peck drill it, but I'm just trying to save a bit of time here. So we're going to do a boring operation on it. We're going to use the same 6mm single flute, so we've not got to take the bit out of the machine. We don't need to optimise the order because it's already picked out the orders for us. I've had it before where it does maybe like 25% of this hole, then 25, 25, 25, it comes back and does 25 each hole. So with this, it will do that hole in its entirety before it moves on. We do need to mess with the heights on this one. I want to make sure that the end mill penetrates all the way through the bottom. So we'll go bottom height, model bottom. We're going to go -1mm. And our top height, so if I can just go in this angle here, you can see that we've got the spiral coming out the bottom. I wanted the spiral to start at the top, so we're going to go top height, model top. We're going to go +1mm, so that means our spiral starts before it touches the material. Passes, we're going to use a ramp angle. That's basically come down in a nice shallow spiral to make sure we're not overloading the end mill. Everything else, I'm not bothered about finishing pass on this one because it's a hole, you ain't going to see it when the bolt's in there. Linking, and we can leave that as it is. So that's that operation done. So next we need to cut out the internal octagon. So for that we're going to do a 2D contour. We're going to select the 6mm single flute end mill that we've already got in. Geometry, we're going to select the bottom here. It's probably not the right way of doing it, but it's the way that I am comfortable with doing it. For this particular operation, we're going to use some tabs to hold the stock in because we don't want the inside to drop out because it could get caught by the end mill and it could scrap the end mill. So we want to hold that piece of stock in there. So we're going to use some tabs. Heights, model top because model bottom because I want to make sure the end mill goes all the way through. We're going to select our top height because we're going to use a ramp angle. I'm going to go 0.5mm just to make sure that we're not trying to push ourselves into the material. Multiple depths, we're going to go 0.5mm. We could go 0.8, but I quite like that. Smoothing, we're going to go to 0.02 because Doug told me to do that, so it's Doug's fault if it's wrong. So linking, we're going to use a ramp angle. We're not going to use a lead in. We're going to use a 2-degree angle to ramp into the material. So that means that when we finish doing our 0.5mm depth, before it starts the next layer, it will ramp into at 2 degrees before it engages the material fully. So it goes down 2 degrees over 22 mil, which is more than enough. Let's click OK. Let's just make sure we're happy with how that looks. So we've not got the tabs there, so let's just go back in. Sometimes it doesn't. Oh no, yeah, so tab, we just need to change the distance for whatever reason. So there we are, 42 millimeters. And there we are. So now we have got our tabs which hold material in. So after that, we now need to do the external 2D contour. So we're going to cheat with this one because I'm already happy with how the toolpath is for the internal one. So we'll right click that, we'll duplicate it. We'll go into that toolpath, geometry, delete the existing geometry, select the outer path, and just click OK because we're happy with how that is. So now we've got that done, we're going to do our final operation for this particular part. We're going to do a chamfer operation just to give ourselves a nice little edge. So we're going to select all these top edges here. So we'll select the holes first. We'll select our inner contour and an outer contour. We're going to change the tool over to a Chamfer End Mill that I've got, which is that one, 6mm 45° chamfer. That's fine. It's a 4 flute, so I'm going to stab in the dark here. Let's run it at 16,000 RPM. Our geometry, we've already selected it. Our heights, we're going to keep that as it is. We don't need to touch it. Passes, we're going to go over a 0.5mm chamfer width, just to give us a bit of, just so you can see it really. Smoothing, we're going to go 0.02 again because the dog told us to do that. Do we need to do a lead in or lead out? I don't think we do. So we're going to take that out. Yeah, and that's it. Oh yeah, just need to unset the coolant because we've got no coolant. Obviously you want to CT around it. So there we have it. Let's just do a quick simulation. In fact, I've just noticed we've got a lead in on these toolpaths. There we are, lead out, we don't need that. I'll change it for that one as well. Lead out, we don't need that because we're ramping in. So yeah, let's just go ahead and simulate the program. This is very important because this is actually what the machine is doing. I don't know why I closed it, I just did. So that's our facing operation, which gets us down to our working height to cut out the flange. Let's do a nice job, nice and quick. And then after that, we're going to bore our holes. 1, 2, 3, 4. Then we're going to do our inside contour. And this little piece here you can see around, that's where it ramps into the material. And we should start cutting our tabs in a second. Obviously we're going down in 0.5mm depths, so that'll be 18 go arounds till we get to our full depth. From 9mm, there we are, we've got our tabs. Just clean up, make sure we're penetrated. Now we're doing the outside contour. Looking good. Again, we're doing 0.5mm depth, so we need to be going around at least 18 times to get to our bottom. And in a second, we should start cutting our tabs. Your laptop can't keep up, bless it. And tabs should be on this next one, I think. Or next one, there we are, look, there's the tabs. And then we should go on to our chamfering operation. Boom, and there we have it, that's our part. So the reason we're using the tabs is A, I don't want to make a set of soft jaws because it's a lot more effort for the one part that I need. Using the tabs holds the part in the material, in the vices, and it holds the excess stock. And with these tabs, you can literally just push the part out of the tabs, and then these tabs can literally just cleanly snapped off with a pair of pliers, so it's really nice. We could use the tape method, where you use like double-sided tape and stick and super glue in between them. I've not tried that method yet. I would like to, just finding time. So now we've got that done, we will do our post up here, and we're just going to name it M62 Flange. Boom. Post. Right, so let's go over to the machine, let's load our end mill, and let's get this bitch cut out. So now we've zeroed our material, we know where our X, Y and Z is, so that's it really. All we've got to do now is press play. So it says it's going to take 18 minutes. Let's have a look. So we've already got our end mill loaded in. We'll just quickly probe and re-get our tool height. And that's it, all that's left to do is get our makeshift cardboard chip guard on and press play. But look at you, I'm going to put the camera in there hopefully so you'll have some better shots. So that's the first operation done. It's not silky smooth because I still haven't trammed the machine. That's going to be something we'll be doing this week. So it's not the best, it's quite rough if I'm honest. But other than that, it looks pretty nice. So we're going to start the next operation now. And I'm just going to bump up the feed rate a bit because it could be faster than that. So yeah, let's start. And there we go, one part. So you can see the jobs of the tabs, holds the material in. So let's get this out of the vise, let's get the parts separated. And there we have it, one lovely flange. Still got to do a bit of clean up from the tabs, but most of them came off quite clean. A bit of sanding work on that. Bob's your uncle. So the important thing is, does it fit? Well, let's find out, shall we? There we are, spanky doodly doo. Of course it fits. Fantastico. And there we have it, our first functional part of the new CNC. Had it less than a week and a half and already making parts. I think that's pretty impressive from a guy which absolutely has no fucking idea a week and a half ago. So now we've got an idea of how a machine works. We're going to push it one step further, and in true Blue Peter fashion style, here's what I made earlier. So this is a head flange for an inlet manifold to suit a K11 Micra 1.3 engine. So just to be clear, this isn't going to fit our particular manifold that we need for the race Micra. But this was a proof of concept that I could program and machine a inlet manifold flange. I'm really happy with it. We have got some limitations, so you probably see by these little dimples here on where the injectors would go. Obviously I'm a bit limited, and without making a fixture plate to hold the inlet, to hold the plate at 45 degrees for the injector angles, it's difficult to machine. So instead I've decided to put these little dimples in, which have actually come out really nice. I wasn't actually expecting them to come out that well defined, but that gives us a hole centre to put a specialised injector drill bit through them. So yeah, really happy about it come out. I didn't really film any of this. I mean, if you've been following on Instagram and Facebook stories, you'll have seen me machining this, but yeah. But anyway, we've got a functional flange, and in true fashion, it's not the first one I've machined. I didn't really film any of this, and I wanted to make you all a video of me machining a part on there. So these are all functional parts, so you could probably say that's not the first functional part. But yeah, I am dead happy with how that's come out. So next on the agenda is we're going to be turning, we're going to be making a manifold that we need for the race Micra this year. And you may have seen in a previous video this bolted to the engine. So this is the 3D printed inlet manifold that I made for the Micra to make sure we had enough room and enough dimensions to fit said manifold. And yeah, so our next project with the CNC is to turn this into metal. So yeah, on that bombshell, thanks for watching, and we'll see you in the next video.